Hello, everyone. Welcome to the EGU2017 General Assembly. I'm Barbara Frère. I'm the EGU Media and Communications Manager, and I'll be your host here at the Press Center. If you need anything, like booking in one of the interview rooms we have available for you, you're welcome to come to speak to me or one of my press assistants at the Press Center info desk. We have organized 8 press conferences for you this week, and as usual, there will be presentations, and then we'll open the floor for questions from those here in the room and those watching remotely who can ask questions using the web chat feature we have available. If you need any documents relating to the press conferences, we'll be uploading them regularly to media.egu.eu/documents, and including some of the press release and a paper relating to this press conference that we have today. And the press conference is on Screaming Clouds, which is the title of one of my favorite abstracts at this year's conference, one of the 17,700 abstracts we have submitted to the conference. And Helen Muri, who is a researcher at the Department of Geosciences at the University of Oslo in Norway, is going to present on behalf of Scientific, who is the lead author of that abstract. And he's a meteorological consultant in Norway as well, and I'll let you pronounce that name because I'm sure you'll do a much better job than I will, where he is based. And I'll now hand over to Helen. Thank you, you can start.
Thank you very much for the introduction, Barbara. So the Screaming Clouds paper is out today in the Wiley journal Weather, and we also have a presentation later today in the Atmospheric Sciences session 134. And I'm sure we're all familiar with the iconic painting of Edvard Munch's Scream, with the figure in the foreground and the Oslo fjord and the city in the background with his very bright and wavy sky towards the west. And the new hypothesis presented in this study is that it was mother-of-pearl clouds that triggered Munch to make this famous painting. And Edvard Munch, he was known to write poems as well. He wrote a series of poems in his journal, and one of these poems stands out in particular, and translated from Norwegian. I went along the roads with 2 friends. The sun set. I felt a breath of sadness. The sky suddenly became bloodish red. I stopped, leant against the fence, tired to death, watched over the flaming clouds as blood and sword. The city, the blue-black fjord and the city. My friends went away. I stood there shivering from dread and felt this big, infinite scream through nature. And this suggests to us that it was a physical event, a natural phenomenon, that Munch witnessed over Oslo. And further to this, Christian Skredsvik, a notable person at the time, and also a painter and a writer, he published a book in 1908 where he wrote about Edvard Munch. For some time he had wanted to paint the memory of a sunset, red as blood, actually coagulated blood. But no one would feel it the same way that Munch had. Everyone would think of clouds. But Skredsvik advised him to paint it, and Munch painted his peculiar scream. Everybody would think of clouds, so this physical phenomenon, it wasn't clouds then. Or perhaps not these regular clouds we have here in the troposphere, as typically associated with weather systems. We're suggesting that the explanation could be found higher up in the stratosphere, at 15 to 25 kilometers altitude, where rare mother-of-pearl clouds appear. And these clouds, they're also known as polar stratospheric clouds type 2, or Nacre's clouds. And you require very unusual conditions for these clouds to form. So typically it has to be very cold, so they start forming at about -80 to -85 degrees Celsius, whilst the average temperature in the stratosphere is more like -60 degrees. And you also need a certain basic humidity present. So that's why these clouds, they tend to appear at high latitudes in wintertime. That's when you get the very cold temperatures. And also on the lee side of mountains, because if you get atmospheric flow up the mountainside, you can transport humidity from the troposphere into the stratosphere, and then on the lee side you also can get adiabatic cooling, so you can get this extra cooling that you need for these type of clouds to form. And that's when you can get the formation of very small ice crystals. And in these clouds, they tend to have very similar sizes of about 1 micrometer. And these clouds, they are very thin. So they are not visible during daytime, typically, because they're so thin. But they do, however, become visible before sunrise or after sunset. So when the sun is low below the horizon, so you don't get any direct sunlight on the Earth's surface, but it still catches the clouds from underneath, because these are very high up in the atmosphere. And that's when you can get these very distinct colorings from the combination of scattering and also diffraction and internal refraction of the sunlight on these tiny ice crystals. So we now have a series of photographs that were taken by the lead author Svein Fikke at a particularly bright and colorful event that happened just east of Oslo in 2014. So these photographs were taken over a time period of 20 to 30 minutes, starting half an hour after sunset. And you see these very colorful clouds and wave-like structures, and these clouds are also changing color with time. And it was actually this event that made the authors think of Edvard Munch's iconic Scream. And we do know that there were mother of pearl clouds in the Oslo area in the late 19th century, because you have observations from, amongst others, a contemporary scientist, Fredrik Karlstørmer, who made some detailed observations and descriptions of these clouds in Oslo in 1890 in particular. He got so enthusiastic about them that he wrote, "They're so beautiful, you could believe you're in another world." And previously it has been suggested that it was volcanic aerosols from the 1883 Krakatoa eruption that prompted Munch to paint this colorful sunset, because very bright sunsets were reported for a while after this eruption. But we are here arguing that this was not the reason for Munch's vision. For, first of all, sunsets that are colored by volcanic dust in the stratosphere, they tend to be very common for up to a couple of years after the eruption, whilst Munch's scary vision was seemingly a one-time experience, the way he described it in his journal. And furthermore, stratification of the stratospheric aerosols, that they are transported from the eruption site at about 6 degrees south to 60 degrees north, it doesn't really support the very wavy structures that you see in the sky in Scream, because after volcanic eruptions, a while after, the layer becomes very stratified and not wave-like at all. And also, mother of pearl cloud events, they can make quite a significant impression on people, especially if you have not heard of them before or never seen them before, as we suggest is the case for Munch, because the sky becomes quite suddenly colorful, and it's after dark, and you're expecting it to be dark around you, and suddenly you have these very bright colors on the sky. And I'd like to use the opportunity to acknowledge the contribution from Jon Egil Kristiansson, who was instrumental to this study, and finally leave you with, to my mind, quite convincing comparison of mother of pearl clouds and Edvard Munch's wavy red sunset or sky. And thank you for your attention.
Thank you very much, Helene, for this beautiful presentation. Would anyone like to ask any questions here in the room or those watching remotely? Everyone is still looking at the pictures.
Yes.
Please say your name and affiliation.
Marko Pekkola from Stars and Space Finland. I wonder, what do we know about the date and the year of Munch's experience? Do you have any timeline on when would that sighting have been? On winter or summer or anything?
Yeah, so from what we understand from not just his journal but also writings from other artists at the time, it seems like would have been the early 1880s. But he took some time before he made what became the Scream, as Christian Skresvik described, that Edvard Munch took a long time processing this, and he thought about this for a long time, and he felt that, you know, painting wasn't enough, and his painting abilities, they were not enough to really describe that vision that he had had. And he also made several sketches before we now have the painting that is the Scream. So this was over a period of several years, and this version on this slide here is from 1910, I think it's been dated to.
Sorry, Jonathan Amos, BBC. So in time of year, I mean, when do these clouds kind of form? Is there a time of year when they're most common?
Yeah, so that's winter time.
Right.
So sometimes you can get them forming, as I said, on the leeward sides of mountain ranges, and to get that sort of uplift of the tropospheric air, you can have stormy conditions or a strong front or something coming through that will, you know, lift the air masses into the stratosphere, and that would typically be the winter time at northern latitudes. Yeah.
And is there any data on their prevalence, how often they're occurring? I mean, with noctilucent clouds, for example, there's this theory that they're becoming more common and that they're moving to more southerly latitudes as well. Is there any information about what mother of pearl clouds are doing?
Yes, I haven't seen any trends in the statistics on the mother of pearl clouds. To be frank, they're very hard to observe, and because they only appear for a certain amount of time. So this particular event in 2014 was visible for, you know, half an hour. So you've got to be a keen observer to catch them. And also, if they do form during stormy conditions, you might also have, you know, weather clouds around, so you might not see them, so their statistics are not very good. But we do have some observations from the 1870s through the 1890s, for instance, throughout this period when Munch was working on his Scream, that we did have sightings in the Oslo area during that time period. But also, considering you need very cold temperatures for these clouds to form, we know with global warming, the troposphere is warming, but the stratosphere is getting cooler as the troposphere is expanding, as it's heating up. So the stratosphere compresses and gets colder. So in theory, you might get at least the temperature criteria appearing more often in the future. But as I said, I don't have any studies confirming that.
Would anyone else like to ask any question? Yeah.
Yes, Bas den Hond, EOS magazine. I have several, if I may. First, you didn't really answer the question: how often does this phenomenon appear? What is the frequency? And I imagine if it's not often, that more people would have been as impressed as Munch was. So you would hear about it more often. That people would report their fright about it. It doesn't seem to be really the case. The other question I have is about the Krakatoa. You mentioned stratification. I wasn't really clear what that was about, and I would be interested in how would you decide whether your theory is really true, because it's still a theory.
Yes, indeed. So how often these appear? Well, in the Oslo area, I'm from Oslo myself, and I have seen these type of clouds once. I haven't lived in Oslo my full life, but for 25 years I've lived there, I've seen them only once. So, I mean, they are rather rare. I think maybe in the 1880s and 90s, you had some years that they were observed, but not every year, and then perhaps up to 4 times a year on special years. So you can also get them forming, for instance, if the polar vortex splits. So you have very unusual conditions, and the vortex splits, and you get strange mixing of air masses between the troposphere and stratosphere. But yeah, so it's very specific conditions that these form under. But I think one of the reasons why we don't have a good statistic for it is that for meteorological observers, you have this list of clouds that you observe, and then you observe is how large a fraction of the sky is covered by clouds and what type of clouds are they. And these types of clouds are not standard within the list of tropospheric clouds, so you're not really obliged to document them, so to say. So with regards to the stratification of the aerosols, so in the stratosphere you have a very high wind shear, so you don't have very strong vertical winds, but you have very strong horizontal winds, and this would mean that you get the stratospheric aerosols would tend to be in a very sort of thin blanket, so to say. So this would give a very different appearance than these more wave-like clouds. So, for instance, if you have clear skies and volcanic aerosols in the stratosphere, the change of light would be a lot more gradual, and you wouldn't get this, sudden burst of colors across the sky. And how do we decide what is the right answer? Well, we don't know, basically, but this is another hypothesis. There are more other hypotheses, but of course we are natural scientists, so we tend to look for answers in nature, whilst the psychologists have suggested that it was, inner torment, and that made Munch want to paint the scream. Whilst for us it's a lot more natural to go out there and look around, and you do come across these type of events, they do make quite a significant impression on you. So, but what actually happened, we don't know. So this will, of course, be speculations.
Thank you very much. Are there any further questions?
Luis Lidón from the Spanish news agency EFE. Do you know if this event has been or has appeared in other piece of art or literature, a part of this one? Thank you.
Well, in the scientific literature, we do have work on polar stratospheric clouds or madrepore clouds, particularly from Antarctica, because the atmosphere is much colder over there. As for in the artist's world, I think you should ask someone else. That's not, to be honest, not my area of expertise. But one can imagine that it has inspired other painters. I know there's one other painting from the early 20th century that also have these mother of pearl clouds in them. Yeah. I'll have to look that up, yes. Sorry.
I'm Mariette Leroux. I'm with Agence France Presse. You say yourself that this is just another hypothesis and that what actually happened, we have no idea. So I'm a little bit curious about the scientific value of what it is that you're doing here. Are you adding something, or are you just throwing the issue into further confusion?
Well, I think it's it's an interesting case because it's a very iconic painting. I mean, it's known worldwide, and we're not convinced by the previous hypothesis that it was internal turmoil, nor that it was the Krakatoa eruption, because volcanic eruptions do tend to appear very differently. So this is our way with our, we're researchers, we ask questions, that's our job. So, it's always interesting. It's a curious type of study, so I don't think we're causing much more confusion, but we're trying to clarify what could be the causes.
You don't seem very convinced of your own answer.
What do you mean?
What is my impression? That you don't seem to be convinced. You're not putting this forward as what you believe to be a convincing, believable hypothesis.
Well, it's a hypothesis that I believe in. What else can I say? It's from my own experiences of these types of clouds. They do make quite an impression on people, as I said, and they can be very vivid and colorful. So yes.
Would anyone have any additional questions?
Just a brief comment. Congratulations. I think that you've certainly picked the right interpretation, because if you just visually look how the Krakatoa eruption, that is the volcanic stratosphere sunsets, look like in images and photographs, those are layered, and they're very very homogeneous clouds. Yes. And very layered. Yeah. Whereas, as you can see there in the type 2 stratospheric mother of pearl clouds, you can see those typical wavy structures and those colors. Yeah. So it fits very nicely.
Yes. Yeah, I agree. I mean, it's particularly the wavy aspect, because if you look at the screen, it's all, very wavy, and particularly the sky. And I think I have one picture of volcanic sunset, if I have it one moment. We just go through it. Bear with me here. Yes, here is a photograph of the sunsets after Mount Pinatubo eruption. So that's just one eruption, but it's, you see it's very different than these pictures of these more wavy clouds. And the photographs that I showed from the polar stratospheric clouds, they were just from one type of event, and they can be very different in how large parts of the skies they're covering, and how frequently they're changing colors, and also the brightness. So they can be very unique and different in appearance. But certainly it's the waviness when they're forming as lee waves, which you would have over the Oslo area, that is part of the convincing argument here, I think.
Just a short comment, like you. I think that Turner has painted a lot of sunsets after the volcanic eruption in the early 19th century. Mm-hmm. So they look completely different. He was an artist as well, and he got the perception of the sunsets and of those days, and it's nothing like this. Yeah.
Yes. Are there any additional questions or comments from anyone here in the room or remotely? No? In that case, we'll finish here. Thank you very much, Helen, for a very good presentation. Thank you all very much for coming. The next press conference is on cities' resilience to climate change, and it starts at 1:30. Thank you.
Thanks, Barbara.
We're going to